Hello everyone. Today we are talking about the uneven heating of the Earth. So, especially with respect to weather. The Earth is a sphere, so that means that we have a three-dimensional round object here, and it is rotating on an axis. Now, other things that you might think about rotating on an axis are with continuous way, like rotating a chicken over a spit. Um, this rotation is often used in cooking as a way of evenly heating your object. But in the case of the Earth, it's uneven. The Earth is not evenly heated. In fact, some parts of the Earth are heated more than the others. And that's what we're going to talk about. This is essentially the source of the seasons. So the Earth's axis is actually tilted. It's tilted at about 23.5 degrees. You can see the picture there on the left or on the right, and you can see how it is tilted on the left and right. And this tilted axis means that the Earth is not, different parts of the Earth at a given time are receiving more or less sunlight than other parts of the Earth. Let's make a note here, just in case, just to put us all on the right path here. Remember that this axis is tilted, and then in a single day, the Earth will rotate around this axis point. So that, if you're here in Africa here, on the continent of Africa, and you'll get rotated around. This is your night. This point will move a little bit during the day, then it'll be sunrise, sunset, etc. until you're back at night again. So the Earth is rotating. I'm not actually sure if I got that rotation right. Now I'm thinking about north, east, south, west. So yeah, it actually rotates this way so that the east gets the sun first. Okay, yeah, so it's going to rotate this way, and the east is here, so east is, northeast, southwest. So if the sun rises in the east, it must be rotating in this direction. Okay, so the Earth rotates on that axis every single day, and in that rotation, the sun appears to rise and fall when it's actually you that's moving away from the sun and moving towards the sun. At noon, you have is the point where you are highest up in the atmosphere. You're highest up and closest to the sun, and then you'll be rotated away throughout the rest of the day, and the sun will vanish over the horizon as the planet moves away from it. And then over the year, the Earth's position around the sun is shifted. So in the winter, this is the position where somewhere like Canada, which is up here, is going to be rotating around this top ring. And because it's up in that top ring, notice that a lot of the day will be spent in darkness. And that's when it is the darkest of the year. That's why the days seem longer, or the days seem shorter in winter. It's because we're receiving more darkness as we're tilted away. In the summer, like right now, we're up in this top section. And so we're still up in the top section, but now that the Earth is on the other side of the sun, being in the northern hemisphere like we are tilted towards the sun. And so we receive more sunlight throughout the day, and our day is longer, and our nights are shorter. Or at least darkness is shorter. So the tilted axis of rotation causes the northern hemisphere to be pointed more towards the sun during our summer, and directly away from the sun during the winter. So think about this. If you took a marshmallow and you placed it on a fire, if you placed it so that this corner was facing the fire, then that is the corner that would start to burn first or start to brown first. And so that is the case in winter for us. We reside somewhere over here on this axis of the marshmallow. And so during the winter, we receive very little we receive less of the heat. In the summer, because we still reside on the top of the marshmallow, we are going to receive more of the heat from the sun, and so our section of the Earth is receiving more heat on average, and so it will be hotter and more cooked up top, and that's why we call this time summer. Okay, so on the right side of the fire, the top of the marshmallow would brown first, and this would be like the Earth having summer in the northern hemisphere, and on the left side of the fire, the bottom of the marshmallow would brown first. And that is also why the seasons are flipped. So in Australia right now, as it's summer right now in the winter in the northern hemisphere, it is considered their winter in Australia, and which resides in the southern hemisphere. And these seasons are flipped in that way. Now we also receive extreme seasons because we are close to the top of the top of the globe. If you reside in the center of the globe, this difference in rotation is actually going to be less severe for you in the summer or winter. And in fact, over the whole year, if you live close to the equator, your seasons will be relatively similar and will stay consistent throughout the year. So this comes from an effect called sunlight density. So here we can look at the way the sun is sending its radiation at our planet. So the radiation hitting our planet hits the whole planet evenly, but because of the surface being curved, only at the point that is directly in line with the source, so directly in line with the sun, is there a high concentration of radiation. As this curve moves away, as we curve away from the sun, the same energy is spread out over a larger area. So, think about this in terms of a triangle or something. So here we have a triangle. We can't actually even draw a triangle here. It would be the slope of it would be too small, so it'd be straight up and down. So this is a very small area. Over here we have a larger area, and this will extend even more so for something like this, where you would have an even larger area. So notice the triangle I'm drawing here is becoming longer and longer for each of these two line tall triangles. So the hypotenuse there of our triangle gets longer. So that tells you that the amount of sunlight is being spread over that hypotenuse, spread over larger and larger areas as we go towards the north or south of this globe. Now our planet is tilted still, so that's probably too much of a tilt. It's only 23 degrees. So our planet is tilted, something like this. So it does matter which of the seasons we're in, as this area of sunlight is going to be important. Is going to be a little bit more complicated because the planet is rotating in this way. Okay, so let's read through and see if there's anything to be gained here. So figure 3 shows how the same energy is concentrated in a smaller area when the rays hit the Earth's surface directly than when they hit the surface at an angle. Therefore, the more directly the rays of the sun hit the Earth's surface, the warmer that part of the Earth gets. Figure 4 shows that it is only regions between the two tropics. So this is the two tropics here, where the sun will shine directly. Because of our seasons, the sun shines directly over the tropics of Cancer on June 21st. That is as far north as the sun gets in terms of being directly overhead. So this is a terminology here. The Tropic of Cancer is a certain latitude on our planet, and that latitude, this horizontal division, this is the northernmost point where the sun is directly overhead. Anywhere from being in Manitoba, we're way past the Tropic of Cancer. We will not notice the sun being directly overhead. We'll always see the sun as being somewhat to the south, even on June 21st. Anyone further north than the Tropic of Cancer will never experience the sun being directly overhead. It might be pretty close, but it will never be directly overhead. The sun will always appear to be to the south in the sky. Similarly, by December 21st, the sun is directly over the Tropic of Capricorn. This is the farthest south the direct sun ever gets. And these are important dates. This is the longest day of the year, usually, and this is the shortest day of the year for us who live in the northern hemisphere. So this is the summer solstice is a one word we call it. So the summer solstice. I don't know if I'll be able to write this. Solstice. And this is also known as the winter equinox. And so that's the shortest day of the year, shortest for us. And the longest day. Okay. Throughout the rest of the year, the area between the two tropics receives the direct sunlight. It is the direct sunlight the area between the tropics gets throughout the year that causes it to be the warmest area on average on the Earth's surface. This uneven heating, with the equatorial region being the hottest and the poles being the coldest, influences so much of our global climate. So think about this, that the sun heats the ground heats the air. If all of the middle, all the center of the Earth, this equatorial region is being heated all the time, then the air there is going to be a lot hotter than it will be in the other areas of the world. And hot air has a bunch of different factors, right? We just talked about how hot air can absorb more moisture. So hot air will be more humid on average. And then colder air cannot absorb as much moisture. So just from a humidity standpoint, we're going to have lots of colder air in the upper climates and or the upper regions, polar regions. So it is no coincidence that most of our deserts lie along the tropics. Of course, that is because of the high amount of heat, but also the rainforests are there, right? So this is because of the higher humidities. Higher humidity is possible. And also for the deserts, right, is higher heats are possible. Is possible. So being directly under the sun, you're going to get a lot of hot air or a lot of heat, and the result will be hot air. But also, you'll also be able to get lots of high humidity because that warm air is able to absorb a lot of water. Meanwhile, the polar regions are very dry because the cold air equals less humidity. And that's one of the major problems that I know I've experienced in Manitoba, is that those winter months are really hard on your skin as the air dries you out. And the characteristics arising from this uneven heating will cause all sorts of other issues, specifically weather-based issues. So I hope you found this video helpful, and we will talk to you in the next one.